Hello students, in our today's class we are going to learn about mensuration in 3 dimension, and our today's topic is volume and surface area of cylinder. Let's take a look at a cylindrical shaped object. Here I am taking an object which you may say is a cylindrical shaped object. Look at the shape of the object. If you take cross-section area of this object, that is, if you cut the object in this manner, then the object will have uniform cross-sectional area. That is, if I cut the object in this manner from anywhere across it, then the cut portions will look like a circle of uniform area whose area will be like this. And as you can see it, this is the shape of the object. So if you consider the number of surfaces of this object, look how many surfaces does it have. It has one plane surface out here, exactly one on the other side, two plane surface, and if you go around this part, it is a curved surface. So total number of surface of this object is 3. We will find the volume and surface area of this object. Before we do that, we must know clearly about the difference between the volume and the surface area. What is volume of the object? Volume of the object is the space that it occupies in the 3 dimension. That is, if you consider this to be a solid object, then the amount of material needed to make this object, or the air that it displaces, is known as the volume of this object. And if you want to paint this object, the portion to be painted, you have to paint it across this side, on the top, the lower part. The portion to be painted is its surface area. Now, we will learn how to calculate the volume and surface area of a cylindrical shaped object. Let us try to draw a diagram of it, and remember that no 3-dimensional object's diagram can be properly drawn on a 2-dimensional surface, that is on the plane of a board. But still we can get a rough idea about the shape of the object once we know how does it actually look like. Here I have drawn a cylindrical shaped object. A cylindrical shaped object can be defined with 2 parameters. The radius of the circular portion is r, radius of the cylinder we call it is r, and the height of the cylinder is h. Now let's see what is the volume of the cylindrical object. If you take a area of this cylindrical part, upper part of it, just the surface area of the upper part, it is pi r square, and if you keep on piling one after another circles like this throughout the length of h, it will be pi r square into h. So it will occupy a volume of pi r square h. So we may say the volume of the cylinder is equal to pi r square h. Number 1. Now area of the surface. Again I am showing you there are 3 surfaces. Plane surface, one on this side, exactly one on the other side, plane surface. Area of this surface is pi r square. Here I am showing you it's a circle whose radius is r. So area of the surface is pi r square. This side is also pi r square. So area of the 2 plane surfaces is pi r square. And curved surface is like this. If you take a thread and go around it, the length of the thread which will cover this is 2 pi r. And if you keep on doing it throughout the length of h, then it will cover up the entire curved surface, which will be 2 pi r into h. So area of the curved surface is equal to 2 pi r h, and if you add the 2 plane surfaces along with it, then the total surface area is equal to 2 pi r h plus 2 pi r square. So these 3 are the basic formula of volume and surface area of a solid cylinder. After this, we will learn about the hollow cylinder. Let us now consider the volume and surface area of a hollow cylinder. Here I have an object which you may consider to be a hollow cylinder. Have a look at the shape of this object. you can consider this object to be made up of two different cylinders. One is the outer one. When I show you like this, there is outer cylinder, and when I show you like this, see, there is an inner cylinder. You may consider a cylinder which has been scooped out of it to make this a hollow cylinder like this. So if I draw it now, it will look like this. Again, let me remind you, no 3D figure can be properly drawn on the two-dimension surface. So if I draw it like this, here is the outer cylinder whose radius is capital R. Radius of the outer cylinder is capital R, and here is that hollow inner part of it, and radius of the inner cylinder is small r, and height of the cylinder is h. Height of the cylinder is h. What will be the volume of the material of the hollow cylinder? Look, in which part the volume or the material is present? The material is present only in this part of the cylinder. This part is hollow. So volume of the cylinder will be, or rather volume of the material of the hollow cylinder will be volume of the outer cylinder minus the volume of the inner hollow part. What is the volume of the outer cylinder? Pi capital R square h. What is the volume of the inner hollow part? Pi small r square h. So volume of the material is equal to pi r square h minus pi small r square h. If you take pi h common, it can be written as pi h times capital R square minus small r square. Now we come to the surface area. Let's see how many surfaces does it have. It has, see, upper part, it looks like a ring. It's a plane surface. Similarly, on the other side also there is a ring. Okay. Outer part is the curved surface of the outer cylinder. Inner part is the curved surface of the inner cylinder. So it has got 1, 2, 3 and 4 surfaces, of which 2 of them are plane and 2 of them are curved. What is the area of this outer curved part? It's the curved surface area of the outer cylinder. So its area is equal to 2 pi capital R of h. Similarly, the inner part is inner curved surface area of the inner cylinder. It is 2 pi small r h. Now, what is the area of this part? What is the area of this part? Well, I have drawn a simplified diagram of this one. See, it looks like a ring whose radius of the outer part is capital R and inner part is small r. So area of this part, that is this portion, is pi times capital R square minus small r square. Pi capital R square minus pi small r square. So similar portion is there on the other side. It will be 2 times pi capital R square minus small r square. So if you add up all the 4 surface areas, 1, 2, 3, 4. This is 2 pi RH. This is 2 pi small RH, the inner curved, plus the 2 flat surfaces which looks like ring on either side is 2 pi times capital R square minus small r square. So this is all about the volume and surface area of a solid cylinder as well as a hollow cylinder.